Hi, I'm Cheryl Leach. In this example, we're going to see if we can discover some information about the first derivative and the second derivative by looking at the graph of our original function f. And in particular, I'd like to know if the first derivative is positive or negative, and if the second derivative is positive or negative. Well, if you remember from the last section, we know that there's a link between the sign of the first derivative and whether a graph is increasing or decreasing. And if we take a look at our picture, you can clearly see that the function is increasing, which means that the first derivative will be positive. But let's remember why that's true. One of the applications of a derivative is that it's the slope of the tangent line. Let's take a look at tangent lines to this curve at several points. We'll look at 3 different examples. So I'm just drawing in some sample tangent lines so I can see what's happening. Notice that the slope of each of those lines is positive, which means my derivative will be positive. So I've answered my first question. Well, now let's talk a little bit about that second derivative. What is the second derivative? Well, it's the derivative of the derivative. And again, we have a couple of different applications for a derivative. First of all, it's the slope of a tangent line. And another application is that it's the rate of change. So we can think of the second derivative as being the rate of change of the slope of a tangent line. Well, let's go back and take a look at these tangent lines that I've drawn in. How are they changing? My first slope, it's a fairly flat slope. And as I move through my interval, those slopes get steeper and steeper. In other words, they're increasing. And we know that when something's increasing, the derivative is positive. So the derivative of the derivative must also be positive. I hope this helps. Thanks.